Let's start in see my screen.
Yeah, visible.
And am I audible clearly?
Yeah, yes.
Okay. Okay. So once again, good evening, everyone. This is the 11th live session for the course Basic Environmental Engineering, Pollution and Abatement. Now, let's start with the brief of the session lectures taught by Professor. So, in this week, we will be discussing mainly about solid waste management that can be generated in through some household activities, through some municipal sewage waste, or some industrial treatment. So, after all these processes, there will be generation of solid, and how do we like what are different source? What can be the type of solid, or what are its characteristics? And apart from that, how do we deal or manage them? So that is all discussed in this week. So let's start with the 51st lecture. And firstly, it was discussed about various types of solids or how on which basis we can classify. So for that, there can be various categories for classification. So firstly, starting with what may be the source of that solid. Okay, so depending on the source, it will have different characteristic and different composition. So for example, if it is a domestic waste and if it is industrial, it can be then industrial waste or it can be some agricultural waste. Now, domestic waste can include some food uh, food material waste. So it can be food waste. Sorry, it can be food waste. It can be some paper. It can be some plastic, right? So some such sort of solid waste can be obtained from domestic uh, by at the end of domestic purpose. Why? So if we see apart from plastic here, uh, food waste and all are biodegradable. So if we look into the hazard of municipal waste and if we compare it with industrial waste, then it will totally different. So the characteristic will be different depending on the source. So another source is industrial solid waste, which can be more toxic. Say, for example, any sludge is obtained or so on. So that can obviously be toxic because it can contain pollution. It can generate pollution because of the presence of pollutants. Now, next is agricultural waste. Hello. Next is agricultural waste. Someone is unmute. Can you please mute yourself? Now, from agricultural waste, there can be some extra cuttings of plants. There can be some fertilizer or pesticide. Okay, so now here this pesticide can be hazardous. Apart from that, all you can say is biodegradable or it is compatible to environment. So depending on the characteristics, now based on whatever the source, depending on the characteristic, it can be further divided into whether the solid is biodegradable or not. Right, so biodegradable and non-biodegradable. Now, whether it is combustible or non-combustible. Right. So, for example, if you have some glass present in the solid waste, then glass, you can say it is not so combustible, right? While, say, for example, you have paper and plastic, then obviously they are combustible. So, depending on that, you actually need to segregate different type of waste. So, you need to know what are its characteristics, right? So, you need to have table or some sort of list in terms of each and everything before you manage the solid. Next is whether it is biodegradable. So if you can derive some sort of uh, make compostable like fertilizer out of it, so whether it is compostable or not, then you can you check for the end usability, like whether it can be reused or what type of material is present. Based on that, you can check whether there is some chances of reusability or not. Now, uh, if we look into the domestic waste which is obtained, so in that case, you can say majorly, like out of all this, so if we are talking about domestic waste, then majorly it will have biodegradable components, as I said, which can be food or tree trimmings, etc. Then there can be some recyclable waste. For example, it can have paper, it can have glass, plastics, and other things. It can have stone, silt, which comes from the sand and dust which exist in the environment. So now these uh, all this solid waste have different characteristics, and every time what we do before managing or before treating the solid, it is always advisable to segregate the waste so that handling specific handling that we provide for each solid, it is easier to provide. Next is agricultural waste. Now, if we talk about the composition of this agricultural waste, then mainly it will have plant-based agricultural residues, apart from some traces of fertilizer,
Ma'am,
pesticides. Yeah,
the screen is not visible.
it's not visible. Wait. Oh, sorry. Yeah, so um, since agricultural waste has mainly agricultural residue, so it will have mainly lignocellulosic compounds, which are the actual composition of any wood or something. So this is nothing but like majorly you will have lignocellulosic compounds out of it. Now, further, if we talk about how to manage this waste, so once we know what all is present in it, like first step is to know what all is present, then we need to know or we need to have some strategy how we are going to handle this. Okay, so first we have identified what are the waste generation source, then obviously we do collection. Okay, right. So say for example, you are talking about domestic waste management, then you need to check for all the possible generation sites. Say for example, generation for if you are talking about your homes, then you just throw the waste into the dustbin, which is collected by municipality, and later it is treated or segregated or transformed or converted to some other forms. So first is generation and collection. So here you find out the source, you and you do collection. Now, as I said, solid have different characteristics depending on its type. For example, biodegradable and combustible, and so on. There can be some multiple characteristics. So it is always advisable, may it be water treatment or may it be solid waste management. It is always advisable to segregate the waste so that we do not require to treat large volumes of that waste, And also there can be specific treatment available for each characteristic of like for different characteristic you may have different treatment. So for that also, or you may require different handling. So in that case it is always easier to segregate and perform the task. So segregate depend on the type. Say, for example, you separate, if possible, biodegradable and non-biodegradable. For example, you can say paper is biodegradable and plastic is non-biodegradable. So you can have one section of waste which has food and paper or some tree trimmings, and you can have some another section of waste which has plastics. So for that, nowadays government also, when they collect the waste from your home, they say that try to do separate collection of waste so that the further task of segregation is easier, or it is not maybe required also. So this is why, because the end transformation is different. Now, there can be some transformation also be provided to some waste in the form such that its handling becomes easy, or the end handling becomes easy. Say, for example, you can have certain waste which has uh, which occupies much large volume. So in that case, if you want to dump that solid, it is not, or it will take much larger space to be when you are dumping, right? So in that case, it is advisable to transform in such form that it is compact and it is less hazardous. So easy handling. Next is you transform such that toxicity is reduced, right? And also reactivity is reduced. Um, because there can be some solid which may have some reactivity, right? So if you are dumping that solid and it encounters a contact with certain thing or material to which it is reactive, so in that case that is not advisable. So reactivity should not be there. So such type of transformations you provide. And next is, or last is, you dispose that leftover solid, which is easier to handle with less volume, with lesser toxicity, with lesser water content and reactivity. And you can dump it in the form of open dumping. You can have a proper landfill sites. Then you can have disposal inside the solid surface. Then you can have barging into the sea, which is usually not practiced nowadays, and you can have feeding to hogs. And out of this, mostly landfilling is the most common because you do not want um, external factors to affect the solid, and which might happen in the case of open dumping, and it can cause further pollution as well. So landfill is the best option you can say, and which is most commonly practiced. Now, there can be different strategies that you adapt for different types of waste. For example, it is always said that to follow reduce, reuse, and recycle, right? So out of all the waste, first you try to reduce, then you try to reuse and recycle. So out of the segregated waste, you see whether the waste is uh, reusable or not, whether the waste is recyclable or not, whether it has some value addition. It can be further modified so that we can have reduced raw material consumption. So in that way, case, you may have different strategies to reuse and recycle the waste in the following forms. For example, for recyclable waste, you can have firstly, if it is non-combustible, for example, glass and metal, then you can obviously separate out glass and you can recycle the glass. Otherwise, if it has some value addition in the form of it, if it can provide heat or not, then that also you can check. Now, plastic is the one which is not degradable at all, or it takes years and years to degrade. So, what is advisable? It is to recycle and maybe you do some transformation and recycle and reuse that waste. Now, apart from this, there can be organic waste content in the solid waste which is available. So, for that, for organic waste, obviously it is biodegradable. Then you provide a biological treatment to it by providing a microbial culture, and then you can obviously have composting to synthesize fertilizers, or you can prepare or you can have a biogas plant to generate gases which can act as fuel. Now, there can be another section of waste which will be inert, so you cannot derive some reactivity and you cannot convert it into some useful form, but you can use it in some low grade construction. So some sand or dust particles, sand. So you can mix it with the cement, or for that you can have a low grade construction. And for hazardous waste, the end treatment is always to burn it because it is not recyclable or reusable. Now moving forward, so the end at the end, what we do with the leftover solid, we dump it into the landfill site. As I said, landfill is the most common and suitable option for dumping. So in that case, there are also different types of landfills. So first is class one landfill, which is where you just dump hazardous waste, right? So this is also one, like this also highlights the importance of segregation, right? Because if you would not segregate, then there are chances that at the end, when you dump all the solids, then hazardous and non-hazardous will also mix, and you can also have fertile land converted into barren land and so on. Such impacts can be observed, right? So in that case, first is there will be different dumping of hazardous waste. Then there can be different dumping of waste that is not too hazardous but requires some special handling. And last is which is very less hazardous and do not require much attention. Say, for example, sanitary landfills. Uh, and here, by hazardous waste, you mean that they can be corrosive, they can be ignitable, they can be reactive and toxic. And also, for this hazardous waste, you are not able to further reduce this toxicity because of some reason. And there is no other option left other than dumping. So that is how you manage. Now, moving forward, it is well known that plastic is one of the major component that contributes to solid waste. And so, if we talk about plastic as a waste, then it is very difficult to manage because of its following properties like non-biodegradability, and it can exist years and years. So, for that, what we try to adapt is apart from reduce, reuse, and recycle, there can be another 2 hours, like 5 hours we follow. So for first is we refuse its use. So instead of plastic, we try to use some paper bags or uh, some material which can be biodegradable. Uh, Next is you reduce its consumption. After that, you reuse that material. Then, once it is totally exploited, like it is reused, then what we can do, we can try to have some recovery or repurpose it. For example, recover the waste without any pre-treatment. And last is you provide some sort of pre-treatment and convert it into some another form, which is recycle. Now, moving forward, there are, as I said, we need to have some sort of transformation to be given to the solid waste so that its handling is easy and its toxicity is reduced, and also we have its reactivity reduced. So to achieve all that, we do some transformation of different types of solid depending on the application and depending on its composition and composition. Uh, sorry, depending on its composition. So first type of transformation that we can provide to any solid is incineration, which is the combustion of the organics which is present in the waste material. Now, incineration, here we supply air, and the supply of air is always very much higher as compared to the stoichiometric requirement. Say, for example, there is C, X, H, Y, O, Z, and there can be some sulfur, nitrogen also. But for that, you require N atoms or N molecules of oxygen to form CO2 and H2O. Now, for complete combustion, this is the theoretical amount of oxygen requirement. But obviously, in practical, if we look practically, then theoretically we require n molecules, but practically it is not possible to provide just n molecules and have 100% conversion of this. There can be n side reactions occurring and so on. So what is always advisable to provide one material in excess, which is here oxygen. So what we do for complete combustion, we provide much excess of oxygen in the form of air, right? So in the form of air, we provide 5 to 50% depending on the type of waste. We provide 5 to 50% of excess air to ensure complete combustion. Now, as you see, the combustion process is exothermic in nature. So here you just need to preheat or start the reaction. After a certain time, it achieves, it itself generates heat so that the process is self-sustaining. Now here, after the incineration occurs, the end products here is just ash and gases in the form of carbon dioxide, monoxide, water vapor, SOx, NOx, right? So these are the vapors or gases that you get from incineration. So now this is what I said. Air requirement calculation, which is nothing but we provide the excess of air. And here there are different steps which are involved in the incineration process. So first is you preheat and preheat the solid, and there will be some moisture content. So moisture will be removed, and after that there can be some pyrolysis occurring, so which occurs in the absence of oxygen, and later combustion occurs because you supply oxygen and all the carbon based material is converted to carbon dioxide. Now, the performance of any incineration process, it depends on how long you are giving or what is the residence time of any feed in the column or for the combustion. Then what temperature range you operate, because temperature range is required. If you do not provide sufficient time inside the incineration column, then since, as I said, reaction is exothermic, so it itself increases the temperature. So if you provide more time, temperature will be higher and more conversion you can have, right? So if you do not provide enough time, the temperature will not be reached and you will not have proper conversion. So you can say time and temperature are interrelated factors that affect the incineration process. And turbulence, which means that like you need to have proper mixing or proper contact between the waste and oxygen. So this is the this is all about factors affecting this process. Now, if you look into the process flow sheet, Then the process involves first is sorting of different types of waste, whether you need or which type of solid just needs incineration. Then once you select that, you homogenize the solid, and if required, you cut down the solid into smaller pieces, and later you provide incineration. Now here, as I said, incineration is exothermic process. So here you have even the gases that you obtain, they are much higher temperature. So from those gases, you can recover the heat, um, and further you can generate electricity, or you can have some sort of end application from that heat, depending on what your requirement is. Now, there can be different types of incinerators that are used here, and it can be fixed bed. So, fixed bed is nothing but you have a column where you just fix the solid, and you pass the air from the bottom, and there will be conversion taking place here. So, there can be different uh, feeding strategies. For example, if this is the bed, you can have supply from bottom. Now you can have different stages which you supply air, so that you may have uniform combustion, because otherwise there are chances of channeling and so on. And other than that, there is also a hybrid where you have multiple feed supply and multiple air supply. Now next is rotary kiln type incinerator, where you have continuous feed supply, and you counter currently feed the air, which so here the lowest temperature air comes in contact with ash, so that heat is recovered, right? And as we move on, the temperature increases of air, and this further you can cool down. And as the combustion takes place, so combustion will result into more and more generation of heat, and that heat is utilized here for combustion. So you can say that as you move in this direction, temperature of air increases. So you can say least temperature air comes in contact with ash, and it recovers the heat in fact from the ash. And here the feed comes in contact with highest temperature air, so that you can have a maximum conversion. So this is the advantage of counter current flow. Next is fluidized bed. So in case you want better contact and more efficiency, and you have smaller sized solid, then what you do, you just use fluidized bed, where you in the presence of air pressure, the solid will remain in the suspension form. So you supply solids from here, and you supply gas from here, so solid will be remaining suspended in air. And so since and they are very much separated, so here the contact is much better of particle or solid with air, to have better efficiency. So these are the types of incinerators. Now the way incinerators has two products. Firstly, ash and gases. Now gases can also take or carry over certain solid particles or ash particles, and there can be some pollutants or foreign materials. So you need to have flue gas cleanup in the form of, first is nitrogen oxide cleanup, then you require mercury dioxide removal. There are certain acidic gases, for example SOx, then that also needs to be removed. And lastly, particulate matter. Right, so these all are the steps that are required further for flue gas cleanup, so that you avoid further air pollution. Now, another strategy for the treatment of or transformation of solid is gasification. So, as compared to incineration, as I said, there is some theoretical requirement of oxygen for complete combustion. So, in incineration, you supply excess air, but in gasification, you supply air which is lesser than theoretical requirement. So, since you supply or have limited supply of oxygen here, so the end products here are majorly CO and H2, right? So there will be series of reaction. I'm not going in detail into that, but at the end of those reaction, you will have majorly CO, H2, there can be CH4, there can be CO2, and by gasification, you generate majorly CO plus H2 product, which is known as syngas, and from this you can separate H2, and you can have uh, like which can be used as fuel in various applications. So H2 is the fuel, and so by this process you generate uh, fuel or value added product. And syngas is produced when you use oxygen as the supply, while if you use air for the combustion to occur, so in that case, producer gas will be produced, which will have much more quantity of nitrogen. So, as I have already mentioned, these are the products that can be obtained. Now, the steps here involved in gasification process is firstly, as I said, it will undergo drying for the removal of moisture it can have. Then it will now as the temperature will be high, you preheat it the solid. So as the temperature rises, the volatile organics they will be um, evaporated and they will get volatilized. So this will be the first step, and later the oxidation of solid occurs, and then you provide the cooling of ash. So these are the steps involved. So now the factors that affect the gasification process is type of feed injection, say for example counter current, cross current, or co-current flow that you provide. Then you can also have gasification agents, say for example air and oxygen. So in case of air, since two inert is also present, then you may need to have more heating requirement and so on. So these all factors affect the process, and all the factors require optimization. Next is the type of heating. It can be direct heating or it can be indirect heating. So in the case of indirect heating, you may need more heat supply because the efficiency reduces with indirect heating. The temperature range at which you are operating and also the pressure of operation inside the gasification chamber. So this is the process flow for gasification where you provide pre-treatment, and in the gasifier you supply oxygen or air where gasification occurs. Now, syngas will be produced, and that syngas undergoes cleanup through various stages. As I have mentioned, there can be some solid particles or there can be some impurities, so that are removed. And after that, you can use some separator to generate pure hydrogen to, as I said, in the fuel cell for electricity generation or for hydrogen powered vehicles or fuel cells, etc. So, if we look into what type of gasifiers that can be used, this includes a fixed bed gasifier where you can have a counter current flow, or you can have co-current flow. Uh, then you can have a fluidized bed through bubbling or circulating fluidized bed gasifier. Then you can have entrained bed where you feed like this is a different um, type here, which is not which may you may not have encountered so far. So here you add both solid and gas from the top, and they are contacted in the gasifier. So air needs to be pressurized here, and solid will obviously fall under the flow of gravity. And lastly, there can be some plasma gasifier where by the uh, electric spark or a generation of high intensity electrons. These electrons are such that it can atomize or form ions of various molecules, which will at the end generate some plasma which you can clearly see. And this plasma will have uh, high concentration of free radicals and other reactive species, which can easily react or have reaction with the organics present. So these are the types of gasifiers used. Now moving forward, another type of transformation that you usually provide is pyrolysis. So pyrolysis is nothing but you do not supply any oxygen at all. So moving from incineration to gasification to pyrolysis, the oxygen supply to any material is reduced. So in incineration you provide excess air. In gasification you provide limited or lesser than theoretical value, and pyrolysis you do not provide at all. So here, since it is in the absence of oxygen, um, the major products that are obtained are char. Then you generate bio oil. There will be H2O, and gases like CO, CO2, CH4, and H2 are formed. Now, so there will be different phases of pyrolysis. And if you talk about instant or primary phase decomposition, then it generates gases and char. Whereas secondary phase involves cracking and condensation. So if you look into the process, supply nitrogen to the pyrolysis chamber. So there is a closed chamber where you supply nitrogen so that you maintain inert atmosphere and there is no supply of oxygen or no contact of oxygen. So the pyrolysis occurs here in this chamber, and the gases come out of this chamber, and the heat is recovered from it from the gases, and also there will be liquid also formed, which is in the form of bio oil. Now the factors that affect the pyrolysis process, it obviously the temperature at which the pyrolysis occurs, so temperature is the deciding factor what reaction chain is occurring. Then obviously the residence time, the rate at which you heat it. So depending on that, you can have slow pyrolysis, fast pyrolysis, and also the feed size. So smaller the size, better will be the efficiency because smaller size, you will have higher surface area and hence better efficiency. Now, bio oil is the major liquid product that is obtained from the pyrolysis. And if we compare this bio oil, then if we compare this characteristics with diesel, then bio oil has very high viscosity as compared to diesel, and also the moisture content is very high as compared to diesel with lesser calorific value. So directly you cannot use bio oil. So there are some strategies which are adapted for the upgradation of its properties. and so that you can have some sort of end use and you can apply it somewhere. So first type of upgradation that you can provide is through filtration, emulsification, or solvent addition, which is not generally used. Whereas you can have some chemical method where you provide some reaction with alcohols so that the higher oxygen content of bio-oil, which is usually observed, um, is removed, and also you provide catalytic deoxygenation to remove the higher oxygen content. Now, talking about different types of pyrolysis reactor. So, this fixed bed and fluidized bed are the most common ones, and these are the less ones used. Next is solid that is obtained from pyrolysis is known as biochar. So it can be used as solid fuel, and it can be used as soil conditioning. It can be used as fertilizer. Then biochar, since it contains a lot of carbon, so you can have activated carbon production from it, and you can have activated carbon synthesis by um, you can say chemical treatment or physical modification of that biochar, or you can have its use as an adsorbent. Now, gaseous product, if you look, so gaseous products usually involve uh, high heat content. Also, it contains syngas, and it has hydrogen. So hydrogen can be used for deoxygenation, or you can say catalytic hydrogenation of bio-oil to upgrade its properties. So whatever you generate in the gaseous product, you utilize it in some form. Say for example, if you have gas with high heat content, then you can preheat or provide the heat to the pyrolysis reactor. So this is all about the lectures that has been covered. Now moving forward with the assignment. So first question is, among the following municipal refuse components, which one has the lowest moisture content and highest or higher heating value out of the following is dash. So wood crates, cotton, leaves, garbage. It's so out of that, wood crates is the correct answer. Next is, everyone is following me, right? Sorry, there was yeah. So sorry, there was some problem with my connection. So I don't know when I lost the connection. So I will resume from the next question. Actually, I don't know why it is giving me trouble today. Yeah. So let's move forward. Second question is Dash is the mostly used for the disposal of residual waste. So options are often dumping, barging into the sea, feeding to hogs, and landfilling. So out of all this, landfilling is the most suitable ones, and as I said, landfilling is the one which is like mostly used out of all. So next question. In order to achieve, achieve complete combustion, various combustion systems required excess air is in the range of dash percent depending on the fuel characteristics and system configuration. So excess air that you provide in incineration is ranging from 5 to 50%, and as we have already discussed, this depends on the type of fuel and the system. Next is water gas shift reaction can be represented as so here water gas shift reaction involves the reaction of carbon monoxide and water to form hydrogen and carbon dioxide. So this is the water gas shift reaction. Next is typical heating value of producer gas ranges from 4.5 to 6, and you can look into the lectures of professor for the detailed value of like for different gases and for different fuels or different types of solid. Next is from the given below, select the correct sequences of steps involved in gasification process. So gasification usually follows these steps. First is drying of solid, then it will have devolatilization, then after that the oxidation of solid occurs, and last is ash cooling. So this order is the first option, and so yeah, A is the correct answer here. Next is find out the most suitable option relating to the catalytic cracking of pyrolysis oil. So pyrolysis oil, or you can say bio oil, we have discussed its property, and that bio oil has um, high viscosity, high oxygen content, and less heating value. So, upgradation or catalytic cracking results into reduced viscosity, reduced oxygen content, and higher heating value so that you can have better application of that bio oil. So, all of the above is the correct answer here. Next is a country, this is the numerical. So, next is a country discards roughly 150 million tons of municipal solid waste. The heating value of those discards is about 6,500 BTU per LB, and the mass burn waste to energy facility can convert those waste to electricity with a heat rate of 16,000 BTU of thermal input per kilowatt hour of electrical output, which means that roughly you have 25% efficiency. Now estimate the electrical energy that could be produced per year if all of our discards were used in this type of WTE system. So what it is saying is there is generation of 150 million tons of municipal solid waste, right? So this is the quantity of waste generated. Now it is given that out the heat content or heating value of this solid waste is 6,000 BTU per LB, which means that for 1 LB of solid, you generate 6,500 BTU of heat. So here so if you check for 150 million tons of municipal solid waste, then you need to check what is the amount of heat that is generated. So heat generated is nothing but weight of solid generated into its heating value. Now here you are given the weight of solid generated in million tons. So 150 million is 150 10 to the power 6 and ton. So ton has the unit which is 1000 kg, right? And here the unit of weight that you are using in heating value is pounds, right? LB represents pound. So you need to convert this um, ton into LB, and so that conversion is given as 1 ton equals to 2204 LB. So if you do that conversion, so 2204 LB. So this is the waste which is generated, right? And so the answer for this comes to be 150 into 10 to the power 6 into 2204, right? So this comes as 3.3 into 10 to the power 11, right? Um, Now, if you want to have the net electric output, so 1 BTU, sorry, 16,000 BTU. So this is the amount of heat that is generated. So 16,000 BTU will form 1 kilowatt hour of electricity. Then if you have 3.3 into 10 to the power 11 BTU, then what will be the heat generated? So you just need to divide this by um, 16,000. So yeah, so there is some mistake in the power. Wait a minute. Yeah, so the correct answer, if you calculate, then it is 121.8 10 to the power 9 kilowatt hour. Sorry, here you need to multiply. This is just weight and sorry, 6500. I forgot to multiply. So now if you divide by 16,000, so answer to me is coming around 1.34 10 to the power 11, which means that uh, kilowatt hours per year is generated. And if you convert into 10 to the power 9, so it will be 134 into 10 to the power 9 kilowatt hour per year. And the answer given in the question is 121.8, like the correct answer mentioned, but there is no option matching here. So you can follow this procedure and you can have the calculation. The answer is not matching exactly here in the option. Next question is estimate the landfill area needed to handle 1 year's municipal solid waste for a town of 250,000 people. Assume per capita national average discards 8 lbs per day. No combustion, a landfill density of 1200 lb per yard cube and one 10-foot lift per year. Assume 20% of the cell is soil used to cover. So here what you are given is for a population of 250,000. For these many people, you have per capita national discard of 8 pounds. 8 pounds per day is generated. And so if you do the total waste generated, it is nothing but so per day what is generated into the total number of people. So total waste generated per day is nothing but 8 into 25 like 250,000. So this should give you 2 into 10 to the power 6 pounds. Okay, you mention the unit every time. Now here you are asked for yearly basis. So total waste generated per year is nothing but this is lbs per day, right? So you just need to multiply with total number of days in a year, which is 365. So this will be lbs per year. So this will come out to be 7.3 into 10 to the power 8 lbs per year, right? So this is the total waste that you need to dump every year. Okay, and for that you need to find the volume. So here to calculate the volume of that waste, density of this waste is given to you as 1,200 lb per yard cube, right? right? So 1,1200 lb of this waste require 1 yard cube of volume, and you are given everything in feet, and you need to calculate the landfill area in feet also. So convert this sorry, first calculate the volume of solid, which will be density is nothing but mass per unit volume. Okay. So to find out volume, divide the mass, or you can say weight, by density. So this will give you 7.3 into 10 to the power 8 divided by 1200. So this will give you volume of the solid waste in this yard cube. So calculate that. So this will come out to be 6.08 into 10 to the power 5. Okay. This is yard cube. Let me do it here. Now, once you have found out the volume of this solid, now the volume of cell, like here it is mentioned that 20% of the cell volume is soil. So, which means that volume of solid is 80%. So, if you find out the volume of total uh, cell, so volume of cell is nothing but volume of solid divided by 0.8. Okay. So, if you do that, it will come out as 7.6 into 10 to power 5 yard cube. Now you need to have volume and area in feet, or feet square or feet cube. So the conversion for 1 yard to 20 feet is 27, right? So so 1 yard means 27 feet. So if you have this much volume, then volume of cell in feet cube will be 7.6 into 10 to the power 5 into 27 cube. Okay. So if on doing that, you will get 1 point. Am I doing some mistake? Wait. Sorry, this is not 1 yard equals to 27 feet. This is 1 yard cube equals to 27 feet cube. Sorry, this is the wrong conversion. So this will be just 27. So 7.6 into 10 to the power 5 into 27 will give you volume of cell as 2052 um 0000 feet cube. Okay. Now to find out the area, so area is volume by the lift, or you can say height. So you can have the surface area of that landfill site, which will be this value divided by 10, which will give you 2052 0000 feet square. Okay. So here, option B is the correct answer. Sorry for the wrong conversion mentioned here. So conversion from yard cube to feet cube is 1 yard cube equals to 27 feet cube. Remember this, right? So option B is the correct answer. Next is fast pyrolysis requires a temperature range of dash and residence time of dash. So correct answer for this is 400 to 650 degrees Celsius temperature and residence time of, since it is fast, so residence time of zero point 0.5 to 5 seconds only. So that's it from my side today. We will meet in the next class. Thank you for joining. We will meet in the next week.